In this video, we are going to study how we can measure independence between two different attributes of a specific population. So this is especially important when you have categorical information in your data set and you're trying to establish a relationship between two different categories of your samples. So what do I really mean by that? So let's focus on an example. Let's assume that we do have a data set that consists of people with their information on smoking and drinking habits. So if the question is to see if these two attributes are independent or dependent in a probabilistic sense, how do we measure this? We can definitely implement an independence test. And if you have two different categories with multiple different attributes, it can come from out of each one. We can use chi-square test for independence. This is not really different than a typical hypothesis test. Instead of t-test, we will have to run a chi-square test here. But we need to know how do we put together a contingency table first. And we already did it in module 1 video, so I'm going to repeat how we do it in R one more time with you. But let's focus on what would be the null hypothesis and what would be the alternative hypothesis, because regardless, we are going to rule based on the p-value again, and then if the p-value is going to be less than our alpha value, we are going to reject the null hypothesis in favor of the alternative one. If p-value is greater than the alpha value, we are going to have to fail to reject the null hypothesis because there is not enough evidence that there's not enough evidence behind the alternative hypothesis. Therefore, we have to stick with the status quo. All right. So in the null hypothesis of chi-square test for independence, we do list the fact that these two attributes are independent. Okay, and in the alternative, we just claim the challenge, right? And then that challenge would be that these two attributes are dependent. Okay, we don't know whether they are dependent yet. We are going to run the test and then we are going to look at the p-value. And if the p-value is less than alpha, we are going to reject the null hypothesis in favor of alternative. Okay, then only then we can claim that these two are dependent. Okay. But first and foremost, we have to know how to put together the contingency table. And I'm going to again remind you what it would look like. All right, so in this example, let's try to look at the Titanic data file. And then let's try to see if the passenger class has anything to do with the survival column into Titanic. So long story short, we are interested in seeing whether the class, passenger class, and their survival attributes are independent. That will be in our null hypothesis, and in the alternative hypothesis, we're going to claim that the class and survival attributes are dependent. Let me first show you what kind of data we are dealing with. You're familiar with this Titanic data set from module 1. As you can see, we do have 4 different columns in the Titanic data. We do have class, whether first class, second class, I believe, third class, and I think there is one more in the data set, crew session in the data set as well. And we do have several other columns, age, sex, survived or not. Survived has two values. It can take yes and no. Let's transfer this into R and then let's work on it, building a contingency table later on and then doing the chi-square independence test. Okay, so this R file is also made available to you. It is under chi-square test.r, okay? First, we need to import our data set. I'll go here, and this time, since it is a CSV file, I'm not going to click from Excel. I'm going to click from text. And I'm going to select my Titanic table. And I want to make sure that the name is showing up right. So yes, it is Titanic. It looks like it is importing it correctly. And I hit import. So it imported my Titanic table. Alternatively, I could have imported it by using read.csv file. If you know the full directory of the Titanic file, you can import your file like this. Since I did not use it, I commented out. Let's display the Titanic table and let's see what it tells me. Looks like it is capturing it correctly. Let's take a look at the structure of Titanic. Let's execute the code on line 6. And if you look at it, you see that those are all understood as a character in R. Contingency table can be constructed by using simply table function in R. Okay, so if you would type help table in R, it is going to bring out this help menu, and it is going to list out how you can actually utilize this table function. It says that table uses the cross-classifying factors to build a contingency table of the counts at each combination of factor levels. Well, long story short, what I want to do is, since my claim is in between class, the passenger class and survived information, I have to put together a table that summarizes how many people falls into different levels of class, like first class, second class, third class, and crew, versus the survived category, whether they survived or not. So I am interested in figuring out, for example, the number of passengers in the first class survived versus, dead, right? And for same information for the second class, third class, and the crew class. Can I put together a quick table like this? So we call it contingency table. In R, if you would like to do it in that way, you just need to import these two columns, right? So first in the table function, the first one is the class and the second one is survived. Let's see if you run this line 8, what it will bring us. Well, it actually saves it under class table variable, right? And let's display class table variable by calling it. Again, this is just a name. You can name it anything else you want. Let's see what it does. Well, it actually looks at the crew and it counts how many crew members falls into survived, or, well, actually survived being no, meaning that no, those are dead, and survived being yes, that means that they survived, right? So we can see that 673 did not survive from the crew members, and 212 of them, they did survive. As you can see, the table function can quickly skip through all the information, all the rows in the data set, and then can give us the categorical information between the class and survived column. Well, if you look carefully, right? So if you look carefully, we do have, age information, sex information, male or female, and you can also just check to see. For example, let's change this. Let's change this contingency table to have information listed between sex and survived column, for example. Right, so survived column is going to be kept here, and I'm going to change this first from being Titanic's class to sex. And what I'm going to be looking at it right now is like females and females, how many of them survived or they didn't survive, right? So let's rerun this line 8. Okay, so it actually did not discard my variable called class table, but it updated it. Therefore, I need to rerun line 10 so that I could see the display here. Okay, as you can see again, again the columns are survived categories, no, yes, but on the rows I do see female versus male. Looks like lots that I lost a lot of male passengers. We lost a lot of male passengers in Titanic ship. All right, but many of them survived too. It looks like there are a lot of males compared to females, but the proportion of the males survived is much smaller than the proportion of females survived. Okay, so yeah, so a table function in R gives you this kind of cross-table information very quickly. And then let's change it to age, from sex to age, and then you'll see the differences here. Adult versus child, looks like for child 50-50. For adults, I can see that it is at least like, twice at least adult passengers lost their lives compared to the ones who survived. Okay, so yeah, cross table or a contingency table can be generated by the table function. So let me change it to class because that's what the problem was. Let's rerun this line 8 and line 10. When I say rerun it, I'm implying that I'm hitting command and return on my Mac. If you're using PC, it should be control and enter. Okay, so you have to have this contingency table layout so that you could run a chi-square test to see whether you do have any dependency between the class information versus survived information, okay? Again, two different variables. So the first one has 4 different categories and the second one has 2 different categories. This could be unlimited number of categories and this could be unlimited number of categories as well. But the most important information here is that you should have 2 variables, okay? So chi-square test is chi-sq.test. This is again stats from the stats package in R. This is the function. All you have to do is to put the contingency table you just created, it is literally this table, inside of this function. And then you can assign it to an object, test object, and this is going to keep it in the memory so that I can refer back to it. All right, let's run this line 11. Okay, it keeps this under chi test variable, and it keeps a lot of information here. Let's display it by running line 12. It looks like it ran Pearson's chi-square test. It gives me x squared information. I don't know the critical region values, so I can't use this, but looks like p-value is very, very small. By default, the alpha value here is 0.05, and it is less than 0.05. So therefore, I reject the null hypothesis. So it is important to remember what the null hypothesis here. Remember, the null hypothesis in chi-square tests always suggests that the information given by these variable columns are independent. While I reject it in favor of alternative, and then the alternative in that case would be the fact that, or the claim that these 2 columns are dependent to each other. That will be my conclusion. Okay, I reject the null hypothesis, therefore the conclusion is these 2 are dependent. So it is basically telling us that depending on the class type, the decision whether, well, not the decision, but the action of being survived or not will be dependent on it, right? Or vice versa. The fact that they survived depends on what type of passengers they were back in the ship, okay? So this chi-square test and different characters that you could refer to. For example, let's take a look at the observed and expected values. So these observed values are literally the same as the ones that we put together by using the contingency table. And the expected values are generated based on the proportions of these class types in these categories that you see. And then the chi-square is basically doing some operations between these 2 tables to calculate the p-value. Well, you don't really need these once you know how to call the chi-square independence test like this. All you need to know that this chi-square test, chi-square.test must have a contingency table inside it, and the contingency table can be created by using the table function in R. Okay, that will be end of chapter 9. Thank you for watching, and I will see you in chapter 10.